Welcome to MRL. In this learning session, we'll study about chord, properties of chord and theorems related to chords. Now, what is a chord? A chord is a line segment joining any 2 points of a circle. And if you see here, A and B are 2 points on the circumference of a circle. AB is joined and therefore AB is a chord. Infinite chords can be drawn in a circle. A diameter is also a chord. Rather, a diameter is the longest chord. A chord which passes the center of the circle is known as diameter, or the longest chord of a circle is known as diameter. Infinite diameters can be drawn as infinite chords can be drawn in a circle. So remember, diameter is the longest chord, or a chord that passes the center of the circle is known as diameter, and that is what is about a chord. Now let us proceed further. Now the different properties of chords. The length of chords increase as the distance of the chords from the center decreases. So if you see here, the chord AB, the length of AB is smaller than length of CD because the distance of AB from the center is greater. Therefore, the length of the chords increase as the distance of the chords from the center decreases. So D2 is greater than D1 here, and therefore CD is greater than AB. CD is greater than AB. If chords are congruent, then the corresponding arcs are congruent. If you have two chords AB and CD, they are equal. AB and CD are equal, and the arc is APB here and the arc is CQD here. So these two arcs are also congruent. That means if chords are congruent, then their corresponding arcs are also congruent. That is, arc APB is equal to arc CQD. Now, congruent chords subtend equal central angles. If the chords AB and CD are equal, then the angle which they subtend at the center, that is angle AOB and angle DOC, are equal. They subtend equal angles at the center. The perpendicular from the center of a circle to a chord bisects the chord. So if you have a chord AB, a line joining a perpendicular drawn from the center of a circle to the chord bisects the chord. OC is perpendicular to AB, AC is equal to BC. Remember that a perpendicular drawn from the center of a circle to a chord bisects the chord, a very important property. The line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. That means if you have a chord AB, if the M is the midpoint of AB, if I join M to the center of the circle, then OM is perpendicular to AB, a very important property again. Now coming to the next important property, equal chords of a circle are equidistant from the center. If chords AB and CD are equal, then the perpendicular distance from the center, that is OM and ON, are equal. So remember that. Now chords of a circle which are equidistant from the center are equal. So if there are two chords which are equidistant from the center, then the two chords are equal. That means that if the distance OM is equal to ON, then the chord AB is equal to chord CD. So that is what you have to remember. Now coming to the segment of a chord. A point on a chord divides it into two segments. If you take a point on a chord, if AB is a chord, if you take a point on it, then it divides the chord into two segments. The segments formed are by internal division or external division. The segments formed when internally divided are AR and BR. So here point R divides the chord internally, that is AR and BR. They are the segments of the chord. If it is divided externally, then SA and SB are the segments of the chord AB. So AB is a chord. The point R divides the chord internally and into two segments, that is AR and BR. The point S on the chord is outside the chord AB, divides the chord into two segments, that is SA and SB. So please remember this. So these are some important properties of a chord, and on this we will be learning about the theorems, proving all these properties one by one in two different parts which we will be learning. Okay, so remember the properties. Further we will also learn theorems in two parts. Thank you.